I constantly bang on about safety. Hmm. Hello, everybody, and welcome back to yet another episode. This will be a continuation of the Electrical Health and Safety in Your Home series. Some of this will be great information for homeowners, landlords, apprentices, and even DIYers. Now, some of you may be a little overwhelmed with the information that's coming, but bear with me. What we'll be talking about today is something extremely important, yet it doesn't receive the appropriate attention. It does, however, get highlighted every time consumers feel like they have time traveled to the Dark Ages and have no power in their respective dwellings. I've always enjoyed educating my clients, as well as having trained many apprentices over the last 20 odd years, and have always believed in empowering consumers with knowledge that can be considered risk prevention. So, here's a little hint. If you live in the current century, whether you consider it utopian or dystopian, you'd find the subject of the topic within your very walls. Before anyone jumps the gun, I'm not talking about rodents or pests. I'm sure, however, since I've brought it up, I may later do a video to follow that topic up. Some of you have probably guessed what I'm talking about is the very essence of what makes your electricity travel from its point of origin or the source to the outlets powering up the very things that keep you plugged into modern society as we know it. Without further ado, I bring to you cables. The primary reason I want to talk about a subject that can be as boring as cables, mainly that the general population that doesn't have to deal with designing infrastructure, as well as some installers or technicians, seem to believe that cables last forever. I can confidently say nothing lasts forever. I have been here in New Zealand for almost a decade now. Majority of countries around the world, cables are tested often. In British domestic properties, landlords were required to test properties each time a new tenant moved in, an annual test, and during a sale of a property. In New Zealand, however, the only domestic testing that occurs would be upon an install, addition, when circuits are altered, or if your power has been offline for over 6 months. So the first big question is, what is a life expectancy of a cable? Cables don't come with an exact life expectancy. As the material compounds are refined and developed, the durability extends further. It's been a common benchmark that a life expectancy based on typical conditions could be assumed to be approximately 25 years. I can presume I'm hearing some gasps, and many of you will have examples of your cables far outlasting that time frame. After all, the copper and aluminium conductors themselves will be operational for much longer. Take, for example, household fixed wiring cables with typical electrical loading and wired using the appropriate wiring guidelines. You'd legitimately expect this to last for 25 years. When was the last time your house was rewired? There'll be plenty of examples of cables where they've been found in relatively good condition up to 50 years after installation, yet it all depends on many factors. Without testing, the only way we sometimes find out is when a problem actually occurs. Kind of like finding out you have rot in your body too late and having to cut that section right out. This poses another question. What determines the life expectancy of a cable? That would be the different environments and conditions in which they operate in that influence the longevity of cables in service. Obviously, the main factor in life expectancy is quality and compliance. It has to be manufactured within tolerance of the standard. Any non-conformance will most likely result in premature failure. Has that quality and compliance been verified? As there are no periodic inspections carried out in consumer homes in New Zealand, the answer is simply not really. Is it the right cable? Does the specification match the performance demands, installation designs, and the environmental challenges it will face during its lifespan? The more closely cables in a circuit are tailored to an installation, the fewer stresses placed on them that they can withstand. Performance demands. Is it the right size? And how is it being used in operation? Take for instance, when someone plugs in a 2 kilowatt heater into a circuit that is already under heavy load, when a current passes through the cable conductor, it generates heat. The higher the current, the more heat that will be generated. This will have a significant impact if the conductor is undersized or continuously running at its maximum permissible load. More current load that a cable can handle can result into fires, especially if incorrect breakers are used. Remember that an efficient circuit is designed to utilize 80% of its maximum load. This load changes when electricians alter and add a lot of sockets to an existing circuit, as well as the aforementioned heaters and such, thus degrading the insulation and sheathing materials over time until they become dangerous and require replacement. Examples of the latter are given in the first two videos I've produced, so be sure to check them out if you haven't already. A link will be placed below. Installation design. How are they installed? Although it's primarily the condition of the installation and sheathing materials rather than the actual conductors that determine the lifespan, as the aluminium and copper will far outlast the PVC sheath, water ingress and pore fixings can also cause corrosion and damage. Joints, connections and terminations are also points of weakness which should be monitored. This again is something that isn't monitored in domestic residential dwellings in New Zealand. Water ingress could be longitudinal along the insulation or through the interstices of a stranded conductor. It could, however, also be radial if the sheathing and insulation is pierced by external objects. For sake of example, if a sharp stone is laid on it over time, or if a rodent chews the cable. Will they be installed in cable ducts liable to flooding? Waterlogged ducts can cause moisture ingress over time through the sheath, given a reason to consider water blocking measures. There are numerous things to consider when looking at the installation design to ensure the cables are not impeded in operation. What external factors are the cables exposed to? The insulation and sheathing materials of cables may degrade over time when exposed to temperatures extreme. UV light, ozone, various chemicals, even excessive flexing or mechanical action. And, as mentioned before, potential attack by pests or rodents. Can the specification be tailored to provide a resistance to this? For instance, think about your automatic gates that should have gel fill Cat 6 cables, but someone has installed regular Cat 5 and just clipped it along the fence rather than enclosing it in conduit for mechanical protection. This, by the way, is the reason of interference you get when you use voice on your intercom, or when your lawn guy destroys your cable due to the fact that it has no mechanical protection suitable to protect it. What's the ambient temperature it's operating in, and has this been factored into the cable calculations and adjusted accordingly? Have the cables been squeezed into a tight hole that impedes its flow and causes it to eventually heat under load? Like us, cables also need space and to breathe. Specification is a balance between all of these factors. If the cable meets the quality and compliance requirements, the better the match and the longer it will likely last. Well, I can go on about such topics forever. I think it's about time to put this to a close, however. In the comments below, please feel free to send me your thoughts and even get in contact about your own wiring if you'd like. I'm hoping you now have an insight as to why it's so important to have your homes checked or tested. Even more so if your home has flickering lights or brownouts as if it were haunted. Please like, share, subscribe, and stay safe. I'll see you in the next one. Bye bye for now.